All right, peoples, let's do some examples from FUN 502, trig ratios number 1. First, let's review our trig ratios that we have. We know that sine of some sort of angle, I'm going to use theta, is equal to the opposite over the hypotenuse. And I know cosine is going to be adjacent over hypotenuse. And I know tangent is going to be opposite over adjacent. And these are ones I would highly recommend that you memorize. However, we do have a nice acronym that we can use that is pronounced SOHCAHTOA. And if we know how to spell this correctly, we know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We're going to use that throughout this sheet. All right, so number 1, it just says solve the ratio. So in this one, our goal is to solve for the x value. If I was solving for this x value, I would multiply by 12 on each side, and I would end up with 12 sine of 40 is equal to x. Okay, this is my answer. Okay, but this is an exact answer, so I like that. We should also do this in our calculadora to actually give it a number. So the way I would do that on this calculator, and all calculators are kind of different, and we'll talk about some of those during class, is I would just push 12, and I can just push sine right away on this calculator, and 40, and blammo, and you can see I get 7 point, let's round to the hundredth, so it'll be 7.71. All right, so I like this answer here because this is an exact answer, and this is the only way we can actually say this answer and be exact. I like this answer, though, because 7.71 value-wise just makes more sense in my head. Let's try number 2. All right, this one's a little different because x is on the bottom. Right away, whenever x is on the bottom, I'm going to multiply both sides by x. So I would have x cosine 52 is equal to 18, and the x's cross off. And let's go ahead and divide both sides by cosine 52. And I would get x is equal to 18 divided by cosine 52. I like this answer because it's exact. But let's calculadora this up to get a value for that. So I think it was 18. So I would do 18 divided by cosine 52. Let's close that parentheses. Boom. And we get 29.2. Let's round to the hundredth. So that's going to be 0.24. So x, and this is an approximation, is 29.24. Let's go down to number 5. And this one says cosine of b is equal to 3 over 5. In this case, we are solving for b. So in order to solve for b, I have to undo cosine. And we had a special function to do that called inverse cosine. And the way we would write that is we would say inverse cosine of cosine b is equal to inverse cosine of 3 over 5. All right, the reason I did inverse cosine on each side is because inverse cosine cancels sine, and I'd be left with b is equal to inverse cosine of 3/5. And I like this answer because it is exact. But let's calculadora this up to kind of get an angle measure for this. So to do inverse cosine in this calculator, I'd push second. In inverse, most calculators, you got to push some sort of second. And then I would do 3 divided by 5, close the parentheses, enter, and be 53.13 degrees when we round to the hundredth. Boom. Okay, so that one we solve for the actual angle when the ratio of adjacent to hypotenuse is 3 to 5. Let's go down to number 7. So in this one it says write the following ratios for the trig or the triangle below. Okay, we're supposed to give ratios. So we're not solving for this a. I want to know just what sine of a, which means I'm going to have to know my side lengths for opposite and hypotenuse. So I'm going to write down my SOHCAHTOA. Again, sine is opposite over hypotenuse. So if my angle is A, I'm going to just mark my reference angle. This is going to be the opposite side. This one is the adjacent, and this one is the hypotenuse. And sine of A is opposite over hypotenuse. So I would do 7 over. Okay, and I don't have a side length for the hypotenuse. However, I do have this thing called the Pythagorean theorem. We got a right triangle here. So I would say 7 squared plus 24 squared is equal to, and I'm just going to call it h squared for hypotenuse. So I'm going to do that in my calculator. 7 squared plus 24 squared is equal to 625 is equal to h squared. I'll square root this, and I'm going to get 25 is equal to h, which is my hypotenuse. So then sine would be opposite over the hypotenuse, which is 25. How do I know it's opposite over hypotenuse? Just from the definition of sine based on SOHCAHTOA. Cosine of A is going to be adjacent over hypotenuse. What's the adjacent side? 24 over and 25. And that's it. Notice how the answers in this one are just the ratios. I'm not solving for the angle. It just says write the following ratios. So sine of A is equal to 7 over 25. Cosine is equal to 24 over 25. All right, tangent, my friends, by definition is opposite over adjacent. Opposite is 7. Over the adjacent is 24. Donezo with that problem. So that's a ratio style of problem, and so is number 8, but let me help you get started on number 8. First of all, this symbol right here is called theta, and it's just a really common variable that we use for angles. All right, so where's theta? Right here. Let's label our sides. Here is my opposite. Here is my adjacent in this triangle, and here's my hypotenuse. And I have coordinates here that are going to help me come up with the side lengths. This coordinate in particular is going to be valuable because it's over 5 and up 12. That means my adjacent side is 5. That means my height here on this is going to be 12. And then since this is like a half circle, and I'm given the radius here is 13, I can just put 13 right here. Or I could have used Pythagoras with 5 and 12. I'd still get 13. All right, so from there you should be able to fill in these ratios using SOHCAHTOA. Let's check out number 1 on the bottom there. So it says find the variable in each diagram to the nearest tenth. All right, so our goal is to solve for the variable. We have a reference angle right here. Let's label our sides. This is going to be the opposite. This side is the adjacent. This side is the hypotenuse. And let's figure out what we're looking for and what we have. So what are we looking for? We're looking for the hypotenuse. What do we have? We have the opposite. So if I'm going to use SOHCAHTOA to write an equation for this one, I want to know which trig ratio compares the opposite and the hypotenuse, and I believe that is going to be sine. So I'm going to write an equation that says sine of 30 is equal to the opposite is 5 over the hypotenuse, which is x. All right, we need to solve for this x. Whenever the x is on the bottom, I'm going to multiply by x on each side. I would get x sine 30 is equal to 5. Still solving for x. I'm going to divide by sine 30. And I'm going to end up with x is equal to 5 over sine 30. All right, let's calculadora that up. So in my calculator, I would do 5 divided by sine of 30. And I'm going to end up with 10. Oh, it's a really nice answer in this case. So x is equal to 10. This is an exact answer, but it actually ends up being exact because this is like a whole number. I'd like you to have both answers. So like normally I would draw a box around this if it wasn't a whole number because this is exact, and then I would use an approximation symbol here. But since it's exact, I'll just say it equals 10. That's a nicer number than 5 over sine 30. All right, let's go to the back side. And I want to do number 3B on the back. And this one, it says find the missing angle measure to the nearest hundredth. All right, here's my reference angle. Let's label our sides. This side's the opposite. This side is the adjacent. This side's my hypotenuse. And what are we comparing here? We're comparing the opposite and adjacent. And from SOHCAHTOA, I got to be able to pick out the correct trig ratio to use in this case. And in this case, the comparison of opposite and adjacent is going to be tangent. So I'm going to say tangent of D is equal to opposite 107 over 128. If I'm solving for this D, I need to undo tangent. The way I undo tangent is with inverse tangent. And the reason I chose inverse tangent is because that cancels tangent. And I would be left with D is equal to inverse tangent of 107 over 128. And we could try to reduce that, but I don't think it's reducible. So this is the exact answer, but we should also calculator this up. The way I would get inverse trig is I would push second tangent, and I would just put in my ratio 107 divided by 128 boom, and I get 39. We're going to the nearest hundredth, so it'll be a 0.9. So it'll be D is equal to 39.89 degrees is the angle. Again, this is exact, which is awesome. This is an approximate. All right, we got a couple more to do here. Let's do this one here. So we have tangent. This symbol here is a Greek letter. That's called beta. So tangent beta is equal to 5 over 12. I want to know what's cosine of beta. So let's go ahead. Let's draw. In this one, we got to build our triangle. I'm going to put beta right here. I just do capital B with a longer line there. And tangent is opposite over adjacent. So this is the opposite. Right here is 5. This is the adjacent, which is 12. And that's going to build my triangle. Here's my right angle. I want to know what's cosine. And we know cosine is adjacent over the hypotenuse. So I would have cosine of beta would be equal to 5 over some sort of hypotenuse. But since this is a right triangle, I can use Pythagoras to figure out this side, which is going to be 5 squared plus 12 squared, which is equal to, I'm just going to call it c squared. I'll label my hypotenuse c. When I square these, I'd get 169 equals c squared. We'll square root that. We may know this is a perfect square, which is 13. So then this bottom hypotenuse is going to be 13. So the answer is going to be 5 over 13 is cosine of beta. That one you're returning a ratio in that one. Let's check out number 6. That'll be our last one we do for today. So we have a 25-foot ladder is leaning against a building at an angle of depression of 20 degrees. All right, so we got a ladder leaning against a building. Angle of depression means relative to flat, it would be 20 degrees. So here's the ground. This is an angle of depression down this way, and I would not recommend putting your ladder against a wall with this angle. It would fall down really quick. All right, so if this angle of depression is 20, these lines are parallel. That means since these are alternate interior angles, this is 20 degrees as well. Now I'm ready to label my other stuff here. This is a 25-foot ladder. So this right here is 25. This is the ladder. Here's the ground. What does the question ask? Write an expression involving cosine that would represent the distance between the ground and where the ladder reaches the building. So that would be like right here. I'm going to call that x. Here's the base of the ladder to the building. We're trying to figure that out. Okay, so let's figure out which trig ratio we need. Here's our angle. This is the opposite side. This is the hypotenuse. This is the adjacent side. I'm getting kind of squeezed here. And it looks like we're comparing the hypotenuse and the adjacent side in this one, because I'm given the hypotenuse, I'm looking for the adjacent, which tells me by SOHCAHTOA, I'm going to use cosine. So I'm going to say cosine of 20 is equal to x over 25. What's the goal of this? Write an expression involving cosine that represents the distance between the ground. So when it says write an expression using cosine, I don't need to use my calculator then. So to solve this, I'm going to do 25 times 25 on each side, and I would get 25 cosine of 20 is equal to x. This is the expression that represents this distance. Let's do that in our calculator just to kind of get an idea what that distance would be. All right, so I would have 25 cosine 20, close that parentheses, boom. So that x value is approximately 23.49er. And donezo with these examples. I would highly recommend for these last two here, get a diagram for those. That's going to help you just set up your triangle. It's going to help you decide which trig ratio to use, and then you can solve it from there. All right, so that's all I have for FUN 502 number 1. Good luck on those problems. Let us know if you have any questions, friends.